Earlier in the course, where we talked about tree traversals, you learned about two types of tree traversal algorithms, depth first and breadth first traversals. Now, I told you that a tree is a kind of a graph. So those traversal algorithms that you learned before also apply to graphs, but with a slight difference. When traversing trees, we always start from the root node. Every tree has a single root node, and all nodes are reachable from that root node. So when we traverse a tree, we'll visit every node in that tree. However, in graphs, we don't have a particular root node. So we can start traversing from any nodes, and with this, we'll only see the nodes that are reachable from that node, not all nodes in the graph. A real application of this is in finding people who are directly or indirectly connected to a person. In this graph, we can see that John is connected to Bob, but Bob is not connected to anyone else. So if we start traversing from Bob, we'll only visit Bob. Our traversal ends here, okay? Now, let's review the depth first and breadth first traversal algorithms using a graph. We want to do a depth first traversal on this graph. With this algorithm, we start from a node and recursively visit all of its neighbors, going really deep in our graph. As you can guess, we can implement this using recursion, but we can also use iteration, as I will show you later in this section. So let's see this algorithm in action. We start from the A and visit this node. Now we look at its neighbors, the B and the E. Let's assume that the B was inserted first. So we go down this path and visit the B. Now we look at the neighbors of the B. Let's assume that the C was inserted first. So we take this route and go to the C. Now, the C has only a single neighbor, so we go to the D, but this node doesn't have any neighbors because there is no link from the D to any other nodes. So our recursion ends here. As you can see, with this algorithm, we go really deep in our graph. Now we go back to the C. This node doesn't have any neighbors, so we go back to the B. We visited the right neighbor of the B, now we should look at its left neighbor. But we have already visited D. We don't want to visit it again. So we're done with the B and go back. Now we're at the A, and we should look at its other neighbor. And our traversal ends here. Now, what if we started from the B? We would visit the B, the C, and the D, but not the other nodes because there is no path to those nodes. That's the difference between traversing graphs and trees. Now let's look at the breadth first traversal algorithm. With this algorithm, instead of going deep in our graph, we visit a node and all its neighbors before going farther from that node. We implement this using a queue. So here we have an empty queue, and we start our traversal from the A. First, we add the A to our queue, and that means this is the node that we're going to visit next. As we visit nodes, we add their neighbors to our queue. As long as this queue is not empty, we're going to continue our traversal, okay? So we start by removing the item at the front of the queue and visit it. That's the A. Now we add the neighbors of the A to the queue, so they will be processed next. Let's say the B was inserted first, so we add the B followed by the E to our queue. Now we remove the B from our queue and process it. So we visit it and then add its neighbors to our queue, the C and the D. Next we process the E, but this node doesn't have any neighbors, so we're not going to add anything to our queue. Now we take out the C, we visit it and add its neighbor to our queue. Next we remove the D and visit it. This node doesn't have any neighbors, so we take out another item from our queue. It's the D again. We're not going to visit it twice, so we ignore it. Now our queue is empty and our traversal is complete. Soon we're going to implement these algorithms in code. But first, let's do an exercise to make sure you understand these algorithms properly.